Welcome back to QuestBond's YouTube channel. And some days back, I posted a video which was on concurrency and parallelism. And I said that it's going to be an 1 hour of video. So 30 minutes on concurrency and parallelism and 30 minutes on does async use threads. So this is the part 2 of the video. In case if you have not seen the part 1, I would suggest to see the part 1 from this tiny URL link which I have flashed on the screen. So in this video, we will try to understand that does asynchronous code use threads at the background? In other words, when we invoke some code which is asynchronous, does it mean that it should spawn threads? Because what I've seen is, when I talk with developers, everyone feels that asynchronous means, multi-threading. Okay. So this video will concentrate on trying to flesh out that does async use threads at the background. But definitely for this video, concurrency versus parallelism, part 1 of the video is the prerequisite, because if you don't understand concurrency and parallelism, then understanding asynchrony would be difficult. So let us get started. Now let me start with a very important statement out here. Asynchronous code, or the concept of asynchrony, does not use threads at the background. And in Csharp, we use the async keyword to implement asynchrony. So even the async keyword does not spawn thread at the background. So when you say that some code is following the fundamentals of asynchrony, that means that it should not be using threads at the background. It should not be spawning threads at the background. So this statement is which is my goal in this video. So in this video, I'll be showing demonstrations, I'll be talking theoretical things, but whatever I will do in this video will be trying to prove this statement. Also, before we proceed, let us try to understand what is in the scope of asynchronous and what is not in the scope of asynchronous. In other words, when you say that your code is following asynchrony, so what is it all about and what it is not about? Right? So asynchronous is all about making your application usable, but asynchronous is not about improving the performance of your application. Asynchronous is all about ensuring that the main thread, the main UI thread or the main thread is non-blocking, but it is not about creating more threads and improving performance. So these 2 points are very important before I start some demonstration. That asynchronous is all about ensuring that the main thread, which is doing the main work, is non-blocking, while it is not about creating more threads and improving performance so that we can leverage hardware, right? So with this, let us start with this demonstration here. You can see that I have this method here called as sum method, and this sum method will be invoked via this static void main method. So it's a very simple C# code which is actually invoking sum method. And inside this sum method, I have a 20 seconds of delay and it is waiting, right? So now what will happen here? The main thread will run. This main thread will go in a blocking mode. The time it calls this sum method, it will go in a blocking mode, and any code after this main method will not execute. So this is the main method, right? Main method code. So this will only execute after the sum method finishes. So in other words, now this code is blocking, right? So to make it asynchronous or to follow asynchrony, what we do in C#, we use this keyword here async, and we put here await. In case you are new to async and await, you can see this video in which I have explained the importance of async and await, right? But over here now, you can see what I'm doing is, rather than making my code synchronous, I have put that word async out there. So now what will happen? The main thread will run. It will call some method, but it will continue moving ahead. It will not wait for that some method to finish. So if you see out here, so this we will just put here saying console.writeLine async code finished. Sync code finishes. Right? So if you see now, what will happen is, let me make this as set as startup. So when I run this code, what will happen is, it's running some other application. Set as start project. Right. So you can see now, you can see it has invoked some method, but the main thread did not wait. The main thread continued executing. So you can see this main method code has got executed. And after 20 seconds, the async will finish and it will say, oh, okay, I'm done. And here is the output, right? So there it is. Now the next thing which comes is that, so can we go and check the threads? Can we go and check the threads and see that is async invoking threads? So many of the developers think that, oh, this code, this specific code out here, this delay code, right, runs on a separate thread. That's what many developers think, right? So let us go and check that part. So what I've done now out here is I have put a debug point in the task.delay. Also, I have increased, the amount of task.delay. So I made it 60 seconds. I'll explain you why, right? So I'm going to go and run this, and you can see now my breakpoint is waiting at task.delay. And the other thing you can see here in the threads. So basically this threads menu here is coming from debug windows threads. So if you go here, debug windows and threads, you can see the thread section, right? So over here, you can see it just has the main thread which is running. Okay. So now if I hit task.delay, many developers think that this guy will run on a new thread. He will spawn a new thread. But now watch here. I'm going to go and hit the next breakpoint, and you can see that the application moved ahead, but you can see that there are no threads created. Also, I can put a debug point ahead so that we can just ensure that this line of code we can catch. But you can see now at this moment, the main thread is executing ahead, but for the task.delay, which is happening for 60 seconds, there is no thread on which this task.delay is running. It is there running by the task, by the TPL system, but the main application has not created any threads as such. We only have one main thread. So I repeat that sentence. Async does not create threads at the background. Async does not create threads at the background. It does not use threads at the background. But now there is a catch here. After 60 seconds, you will see something. So you can see now, let us wait. I hope that already 60 seconds have finished. And that's why I made it 60 seconds so that I can do the explanation part. Now there it is. You can see once the task.delay has finished, you can see that there is a worker thread out here. Now the question comes is that you said that it does not create threads. So while the delay code was executing, it did not create threads. So why after the delay thread, there is a thread created? Why do we see a worker thread out here? Worker thread means a thread which is other than the main thread, okay, which is spawned. So let us try to get this answer. What is this extra worker thread which is created, and what is the purpose of it? If you go and see what this worker thread is all about, if you go and just maximize this, you can see that it is saying resuming the async method. So in other words, this is a kind of a callback, from the task.delay saying that, hey, I am finished, right? And please start resuming from the point, where you were waiting. So this is not the real main thread on which the task.delay has ran. This is just a thread of callback, which says to the main thread that I have done finishing and please start resuming. Can you see that resume async method? Please start resuming from this code onwards and continue ahead. So this thread is a very, very light thread, and it is not created by the main application. Please note, I did not use the word new thread to create it. Now let's go into the root problem, that why developers think that threads and asynchronous code are one and the same thing, or whenever we are using async keyword, it uses threads internally. Why do developers think like that? When developers are posed with this problem that we have a thread which is blocking, the next thing what they think is that, oh, just create one more thread and remove that blocking code into that thread. So in other words, the but obvious solution there, what developers think is that if one thread is blocking, why not just create one more thread? In other words, over here, if let us say this code was like this, right? .wait. So many of the developers, what they will do here is, they will just create one more thread here. So this sum method is blocking, right? So a lot of developers just do this, so the but obvious solution, what they think is just create one more thread and run that blocking code on that thread. So if you see here, now this will also work. Definitely this will work, right? But in this case now, you will be creating threads. The main application is creating threads. If you see the previous part of the code, there the main application was never creating threads. So this solution is also right, that you removed the blocking code into a separate thread, right? So if you see out here, you can see now we have two threads out here. One thread on which you can see now there are two threads out here. One is the main thread on which the console.read is running, and the another thread on which the task.delay is running. So you can see now we have two threads. If you remember previously, we had just one worker thread or one main thread, right? So many developers, when they are faced with this problem that one thread is blocking, they just go and open another thread. So in other words, if one person is not enough, it is human nature, right? We just say, okay, if one person is not enough, why just we not have one more person to do the work? So that's why a lot of developers think that if you want to implement asynchrony in your code, you need to just create more threads, but that's a wrong thought process. Now for this simple code out here, it is okay that you have created a thread and you have made your application running. But now let us say I want to go and call this some method 1,000 times. So let's say there's a big for loop here, and this big for loop says that I want to go and invoke this method 1,000 times. So in this case, what will happen is you will have thousands of threads created, isn't it? And remember that every thread what is created out there will consume RAM, will have its own working memory, or will have its own space under which it will run. It will also utilize some core because it's going to go and run on a hardware. So what is happening out here is that in order to cut an apple with a knife, you are using a saw. So yes, the apple will get cut, but it will be resource intensive, right? So for small things, it's okay that you do not understand asynchrony versus thread, but when the problem amplitude becomes high, then at that time, definitely, you need to understand that is it really performance, or is it really just that we want to make our application usable? But now the next question which comes is that how is this all thing running? I mean, like if there is no threads at the background, so how is it actually working, and how is only one thread doing all the thing? So let me tell you a secret out here. So this is basically synchronous, but at the same time, there is a concept, something called as state machines, which they have implemented internally. So let me explain that concept. So you can see here, what I've done is I've done some more tidying up the code, because the state machine concept is very difficult to understand. So what I've done is I have put some code 1, code 2, code 3, such kind of console.write line. So you can see before the async method gets called, I have put here code 1 and code 2. Before the task.delay executes, I have put code 3 and code 4. After the task.delay finishes, I have set code 5 and code 6. And in the main, before the main, when the main is executing, I have put 7 and 8. So you can see that I have put some codes around task.delay before the method is called, before the main finishes. So I put some console.write line statements out there. So let us try to understand that what happens internally. So if I go and build this application, so I will go and I will just build this whole application, and let us go and see inside the IL code what is generated, right? So I'm going to go and pop up ILDSM. ILDSM is a tool which is given by which we can go and we can see the IL code. And this code at this moment is generated out here. So I can drag and drop this code out here, and let us see what exactly do we see. So you can see here, this is the ILDSM code. So if I go and see, you can see that there is a main method. So inside the main method, we have code 1, we have code 2, we have code 7, code 8, right? You can see now there is something called a sum method. And in the sum method, there is a move next, they have created. And inside this move next, if you see, they have created code 3, code 4, which is state 1 must be. And then they have created code 5, code 6, which is some other state. So in other words, internally what has happened, what they have done is they have divided your codes into small chunks. In other words, if I put in short sentence, what they have done is they have created these two codes as one unit, this two codes 7 and 8 as one unit, these two codes, these three codes, that is 3, 4 and async await delay as one unit, and code 5 and code 6 as one unit. So in other words, what they have done is internally they have created, I can say partitions, right? Or I can say chunks of code, which has 1, 2, 3 and 4 segments. That's what they have done, right? So internally, there is a state machine concept, wherein they have divided the code into separate chunks. So now when the main code starts, right? When the main thread starts, the application says, okay, start executing code 1 and code 2. So he just goes ahead and executes code 1 and code 2, right? After that, he says him to execute code 3 and code 4 and also the task.delay. So he says just execute code 3, code 4. So he goes ahead and executes code 3, code 4. Afterwards, he says now execute code 7 and code 8. Remember, it's a main thread. He's like a dog. He's saying, okay, you execute this. He just executes it. So that then afterwards he says, okay, execute 7, 8. He just executes 7, 8 and then waits for console.read. Now this task.delay then comes back after some time and it just tells to the main thread that now execute code 5 and code 6. So he actually gives him the code and says, now execute this code. So internally there is a state machine. It says that, so what is the state? This is state 1. So execute this code. This is state 2. So execute this code. So internally there is a state machine which drives the main thread saying that which chunk of code to be executed. And the application, like a dog, just executes that code one by one. So if you really think about this whole thing is synchronous, but because of that state machine thing, we think that this is asynchronous. I would really encourage you to see this video, which I'm flashing on the screen, which goes very much in detail of how exactly this state machine works, right? So I will not go into detail of this more, but the basic thing is that internally, your code is divided into separate chunks of code, and the application main thread just keeps executing that code depending on different states the application goes through. So as soon as the state changes, it just says that execute this 3 lines of code. As soon as the state changes to something else, he says now execute this 3 lines of code. So basically the application main thread just keeps executing codes after code, not knowing that he is actually executing a synchronous code or is actually executing an asynchronous code. Also, I would like to bring to your notice a very important concept here called as the synchronization context. And many developers are not aware of synchronization context, and because of that, even though async and await does not create threads, but they still create threads if they do not get the synchronization context. So let me explain that. So now we have a main thread here. This main thread actually runs everything. It runs the task.delay. It runs code 1, code 2, code 3, code 7, code 8. It is the only person who runs everyone, right? That's our assumption. So what I'll do is, in order to really see that this is true or not, I'm going to go and display the thread ID. So when this code 2 executes, let us go and display the thread.current thread, thread dot whatever is the current thread. Let's display the ID of it, right? So we'll display the ID over here, as well as what I will do is I'll display the ID in this code 6, right? So let us go ahead and display the ID here as well. Okay. And let's remove this. Let's put a small, let's make the delay a little bit more smaller, right? So now you can see here, my assumption is that because this is run only by the main thread, this thread ID out here and this thread ID out here should be same. It should not be different, right? So the code which the thread which executes code 1 and code 2 and the thread which executes code 5 and code 6 should be one and the same, right? So let me go and run this. So you can see now code 2 is actually running on thread ID 1, right? So my expectation is that our code 6 should also run on thread ID 1, right? But let's see what happens. So 20 seconds of delay I have, so we need to wait and watch. Come. Oh, okay. I don't know what happened there. I just pressed enter and I'm seeing the output. So you can see here, what is out here is this code 5 and code 6 actually ran on a different thread number 4, and this code 1 and code 2 actually ran on thread ID 1. So in other words, internally the application created a thread. So what really happened? So this is what really happened. First, the main thread ran, it ran code 1, code 2, it ran code 7, code 8, right? When the task.delay finishes, right, he actually sent out a message back through another thread saying that I'm finished. But now when it came to the application says, where will you run now? Because the current context is lost. In console application, we do not have a current context. Okay, so he says this some method's current context is lost. So now in order to run that code, the application created a new thread. If you see the same code in a WinForm, you will not find that a new thread is created, because in WinForm, there is a synchronization context which synchronizes the async thread or the async code with the main thread. But in case of console application, you do not have it. So you will see that because when it re-enters the application, he does not find the thread, he creates one so that he gets executed. Okay. But if you see this in a WinForm, so you can see that I have a simple WinForm out here. And let us see that in a WinForm, because of the synchronization context, you will see that he does not execute on different threads. So let us see this. So here is a simple WinForm I have. And in this WinForm, what I've done is I have put a console.writeLine here. I'm going to go and debug, and also I'll put a debug point here. So in WinForms, in other types of applications, they have a synchronization context, which ensures that any kind of async code gets executed in the same thread. Okay, so let's see this. So I'm going to go and start running, and I click on this debug. You can see only there is a main thread, and that is understood. Now, if you see here, this thread.manage thread ID is 1. Look at this. It is 1. Manage thread ID is 1. So we expect that in the same thread, this code also should run, right? So I'm going to go and run this. That's where you can see task.delay has started. And after task.delay, I have put a breakpoint here. So remember, previously the managed thread ID was 1. So over here also now the managed thread ID has to be 1, right? So let us see if that works or not. So remember, in console application, we do not have a synchronization context. So there it is, you can see. And if I go and see, can you see now it is 1? So that means that here we just have only one thread which is actually executing all the code, which is sync or async. And you can also see here that there is a worker thread, but remember this worker thread is just a callback saying that I have finished, and you have to execute the code after this. So this worker thread out here is not executing either task.delay, or it is not executing the code after the task.delay. So because of the synchronization context, in case of WinForms and WPF and other application, the async actually follows the common thread concept. So here is a summary of what we have learned. So we said that async does not create threads. It has a concept of state machines, wherein the code is divided into chunks, and the main thread just goes and executes every chunk depending on what state it is. Without the synchronization context, async has no sense. Why? Because then it will keep spawning the threads. And asynchronous is a form of concurrency, you need to understand, because in concurrency, we have only one thread which actually does all the work. And in asynchronous code also, we should have only one thread which does all the work. And the last important point is that asynchrony is all about usability. It is about ensuring that we do not have non-blocking main threads, while threads is all about performance. So I hope that, the confusion around these 4 keywords, concurrency, parallelism, async, and threads is removed. Thank you very much.